Alright, Unit 15, Day 3, last day of new stuff for a long time. Converting polar and rectangular, which should sound familiar because that's what we did yesterday. But yesterday was points. Today is going to be equations. So very similar stuff, but different stuff because it's points versus equations. The conversion equations are still all the same. X equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. Although we don't really use that last one very much today. I don't know if we use it at all today. So that one's really more for points, but the top three that we used yesterday we'll use again today. So let's do some from polar to rectangular. So first example, we can jump in right away with examples because we already have the three equations that we'll need. R equals -3 secant of theta. Okay, well that's some sort of graph in polar, but I don't really want to do graph in polar. Let's change it to rectangular. Now, I really like this stuff to show up so that I can make the swap. There's definitely nothing involving secant, so let's change secant to, what's secant the same thing as? Yeah, cosine but flipped. So let's change secant to 1 over cosine. So -3 over cosine. What's that? Like this is what I started with. R equals -3 secant theta. So the -3 is still there. And I'm trying to make it look like one of these equations. This is a little bit of a game. Like I got to finagle with this to make it look like something up here. So any ideas of how we could make this match something up there? I mean, we have to use an algebra thing. We're going to use our algebra to make something from up here appear in this equation. Well, what if we multiplied both sides by cosine of theta? Then on the right-hand side, on the left-hand side, we'd have r cosine theta equals -3. And what's r cosine theta equal to? X. So we change that from a polar equation to a rectangular equation. But it takes some algebra, and not just any algebra. It takes some algebra, not creativity, but algebra foresight, I guess, of how to rearrange things to get them what you want. Let's see, r cosecant theta equals 7. Well, that's not one of my options either. Then there's definitely no cosecants involved, so let's change cosecant to sine, or 1 over sine. Well, that's not really helpful either. So this one takes a little extra foresight. Let's move the sine theta over. So r equals 7 sine theta This one I wouldn't really expect you to know the trick to make this one work. But there's something I can do to both sides that would make the right-hand side work and make the left-hand side work. Like if this just had an r, it would be great because r sine theta would be y. But I can't just put an r on one side. That's very illegal. If I multiply r to one side, what do I have to do to the other side? Multiply by r. But that works out okay because then I get r squared. And r squared is equal to x squared plus y squared. So x squared plus y squared equals 7y. And that would end up being some kind of circle. I don't know if you remember formulas for circles, but they look something like that. All right, let's do one more. And then we'll switch to rectangular to polar. R equals 2 cosine theta plus 7 sine theta. 2 cosine theta plus 7 sine theta. Again, it requires a little bit of creative algebra to make things work. Any idea what we could do to that one to basically make all three pieces of that work? It'd be nice if that had an r, because then you'd have r cosine. It'd be nice if that had an r, and it'd be okay if that had an r. So let's just multiply everybody by r. So r times r equals 2r cosine theta plus 7r sine theta. Again, a little bit of creative algebra to make it work. R squared would be x squared plus y squared. R cosine theta is x, and r sine theta is y. So you definitely need to practice these. And some of you're kind of getting to the point, maybe it's just that time of year where you watch me do the notes, like you're all good students in that regard. Most of you take the notes, and then it gets to the homework and you're like, I know how to do these. I'm fine. And sometimes you're right. But this is a little bit different. These are kind of weird problems. You got to play with them a little bit and figure out how to make them work. So I know some of you, not even most really, like to put off the homework, pass on the homework. I get it. Don't do that with this section because this is a little bit trickier. And you've got to get in there and try these until you get the hang of the different types of problems. And work on this creative algebra. I don't know what else to say. You're not solving for anything particularly. You're adding extra stuff and moving stuff around in ways that we don't normally do it to make other things work. Let's do a few rectangular to polar. So we'll start out with x's and y's. And we want to land with r's and thetas. Now, most of these are easier. Most of them. There's still a couple that are a little bit weird, but most of them are pretty easy. So if we start with y equals 7, what does y equal? R sine theta. So I can replace y with r sine theta. And then I'm done. That was an easy one. These are a little bit easier because there's direct substitutions for x and y. X is r cosine, y is r sine. The other ones weren't really that easy because there isn't a way to just directly substitute for r or for theta. You have to do some algebra tricks on the first part. For this section, it's more straight substitution, less trickery involved. In fact, why don't you try that one? 4y minus 3x equals 2. You know what y is, you know what x is, make the substitutions. So hopefully you got that. All you had to do was replace y with r sine theta and x with r cosine theta. And now you have an equation with r's and thetas. Again, these are a little bit easier because you have an equation for y and you have an equation for x. So you just plug them straight in. The r's and the thetas are the trickier one. One more example. X minus 2 squared plus y squared equals 25. Well, let's not do the direct substitution on this one yet, because it looks like I'm going to get an x squared plus y squared when I multiply this out. And x squared plus y squared is r squared. So let's FOIL first. Hopefully you're well past the point of actually having to write it out to FOIL. You can FOIL in your head, I hope. I hope wrong, or my hope is ill-founded. Is that a word? Sounds like I know what I'm talking about. Let's see. Well, now I can group the x squared plus y squared. X squared plus y squared is r squared minus 4 times r cosine theta. And then, just to clean things up a little bit, I'll move the 4 to the other side. Equals 21.
Couldn't you also square root both sides?
No, because if you have a squared plus b squared equals c squared, that is not the same thing as a plus b equals c. Right? Otherwise, we would never learn the Pythagorean theorem. We would just say, well, why do we need that? We'll just do a plus b equals c. So, I mean, you could square root both sides anytime you like, but the square root of a squared plus b squared is not a plus b. My Algebra 2 teacher long ago had a poster with Aggie math things on it, and that was one of them. She was not an Aggie, but that was one of her pet peeves. Square root of a squared plus b squared is not a plus b. So apologies to the Aggies out there. Most of them know better. All right, today's assignment is worksheet 3. I'll get the key up on Schoology here before long, and you guys have time to work on that. Probably finish it. Andrew?